Hello and welcome everyone. In this video we will see what are the evolutionary advantages and disadvantages of bipedal locomotion. Welcome to the question answer channel. Thanks to Barczuk, ClaireJordan, George Farang and ClaireJordan for answering this question. We'll start with Barczuk's first answer.
These are the advantages and disadvantages of bipedal locomotion. Moving around on 2 feet uses less energy than moving on more legs. This is because 2 legs are like a pendulum. When they swing forward, their momentum can be used to move. Research on chimpanzees walking on 4 legs and humans walking on 2 found that we use only about 25% of the energy that our cousins need to use to walk the same distance. It is more challenging to balance the body on 2 legs, and there is a more significant risk of a fall and injury. It frees up other limbs for other uses. In humans, it was vital for the evolution of our technological intelligence because we use our front limbs to manipulate our environment. The complexity of our mind coevolved with the dexterity of our hands, which take up a large part of our brain to operate. The front legs of some dinosaurs evolved into wings when they became birds. Although in some dinosaurs, the arms evolved to be almost like small stumps with little or unknown to us use. Bipedal locomotion elevated the head and the eyes higher to be able to see further away. It helped in avoiding predators and in seeing or smelling prey from afar. It's easier to reach something higher up in a bipedal position, like fruits on the trees. Front limbs can be used for self-defense, and humans use them, for example, for throwing rocks or punching. Therizinosaurus dinosaurs, pictured above, had enormous claws. The heart needs to be stronger to pump blood to the brain, which is higher on 2 legs. The speediest quadrupedal animals can achieve higher top speeds by galloping than the fastest bipedal ones on the ground. They can propel themselves by using the muscles of their trunk. Humans have unique bipedal locomotion in which our body is not balanced by a heavy tail, like in many extinct dinosaurs. It also evolved relatively recently in us and our bodies are not fully adapted to it yet. We get problems with our back and knees. It also makes it challenging to carry babies during pregnancy and makes it difficult to give birth. Humans evolved within mammals that are synapsids. In their early history, they lost their tails. They later re-evolved them, but they never became as massive as the ones that diapsids, aka dinosaurs, crocodiles or lizards, have. With huge tails, they could balance their bodies and many became bipedal. Surprisingly, even the ancestors of crocodiles are thought to have walked on 2 legs. To this day, their hind limbs are somewhat bigger. Synapsids remained quadrupedal and we, kangaroos and a few others are the oddballs within this group. The question was, what are the evolutionary advantages and disadvantages of bipedal locomotion?
The following answer is from ClaireJordan.
I'd say sophakas, a type of large lemur, and bears, especially black bears, who already use bipedal locomotion for part of the time, followed by giant anteaters and pangolins, who walk with their bodies balanced horizontally but are able to do so with their front paws lifted up off the floor. And of course there are many hopping bipedal animals, such as jerboas and wallabies, who might conceivably develop to walk instead of hopping.
What do you think? We will continue with George Farang's answer.
However you enumerate them, the fact that we are weighs on the side of advantages. Probably doesn't work well for a scallop, though.
What do you think? We will continue with ClaireJordan's answer.
About 21 million years ago, stem catarrhine primates split into Old World monkeys and apes. Old World monkeys ran along the tops of branches on all 4s. And apes brachiated, swung under the branches by their hands. Presumably they were exploiting different types of trees and undergrowth. Brachiation led to apes developing an upright body with wide chest and shoulders. They could still walk on the ground on all 4s, but unlike monkeys they could also manage quite well on their hind legs. We think our last common ancestor with chimps and bonobos was less bipedal than us, but more bipedal than them. This is Sahelanthropus chidensis, shaved to show the anatomy. He would have been furry, who was either our last common ancestor with chimps and bonobos, or a close cousin of it, or one of the first on our line after the split. That semi-bipedal population split into 2 groups. One lot moved into dense cover and went back to being more quadrupedal, like monkeys, in order to pass underneath dense branches. The other lot moved out onto the plains and became more bipedal in order to see farther and walk long distances with less energy expenditure. Becoming more bipedal freed up our hands to become more dexterous and make better tools, which in turn made it worth expending the extra energy required by bigger brains. The fact that our ancestors were brachiators also gave us mobile shoulders which could be adapted for throwing and punching.
This is the end of the video. Thank you for staying until the end. If you found the answer you were looking for, please leave a like and subscribe, it would help us a lot. The video is over, you can continue discussing this question in the comments, or find another question that interests you. See you next time.